Today we will be looking at tables and figuring out which family they belong to: linear, quadratic, exponential, or square root. Some of these will be review, like linear. We've already looked at those. You have a linear shape if you have constant or the same first differences between the y values for evenly spaced x values, which means you check to make sure the x's are all spaced out evenly, and then you figure out the differences between the y's, which means you take y2 and you subtract y1. If you get the same number every single time, then you have a linear function. If you have constant second differences between the y values, so if you take those y's and subtract them, and you get the same number every single time, then you have a quadratic function. If you try the first differences and you try the second differences and you don't get a constant number either time you try that, you could keep going and try to see if it's cubic, but I'm going to go ahead and tell you that there aren't going to be any cubic ones necessarily in this section. So if those two don't work, then you can try exponential. That's when you get a constant ratio. So you're going to get the same number between the y values for evenly spaced x values when you divide them. So now it's going to be y2 divided by y1. If you do that and you get the same number every single time, then you will have an exponential family, which looks like the shape of that graph, and you can see the parent function right there. And then the last one is square root. It's kind of like the quadratic one. Remember on quadratic how you have constant second differences between the y values? Square root is constant second differences between the x values for evenly spaced y's. So this time, if you take the x's and subtract them and you get the same number on the second try, then you'll have a square root function. And this one we haven't really looked at before. We've looked at the shape, but not from a table. And so you can see the shape is kind of like that. So let's try it on example 1. Let's look at the x values first. So the mass is the x. We're looking at the mass of an object when it's attached to a spring and how long that spring uncoils the more mass you put on it. So the length of the spring would be the y's. So the mass is going up by 1 kilogram each time. See how it's 4, 5, 6, 7, 8, 9, 10. So those are all evenly spaced. Great. Now we can look at let's try the first differences between the y values. So we're going to do y2 minus y1, which means we take the second y value and we're going to subtract the first y value. So we're going to say 31 minus 30.2. When we do that, we get 0.8. Then we're going to do it for the next set. We're going to do it for these two. So now the 31.8 becomes the second one, and the 31 becomes the first one, and we'll do 31.8 minus 31. When we do that, we get 0.8. We can do it for the next two, and the next two, and the next two, and the next two, always doing the second one minus the first one. And when you do that, you get 0.8 every single time. So since we got the same number on the first try, the first differences were constant, we can say this is a linear function. If you were to plot those points and make a graph, it would be a straight line. So basically, that spring gets about 0.8 centimeters longer every time you add 1 kilogram of mass to it. All right, let's look at 1b. First, let's check the x values. Are those going up by the same number every time? It doesn't really look like it, but let's look at the y values. 2, 3, 4, 5, 6, 7, 8. The y values are all evenly spaced out. So why don't we skip over our first three options and automatically try the square root one? We're going to see if those x values are constant on the second differences. If that happens, then we'll be able to say this one is square root. We shouldn't really try the other ones because to begin with, we don't have evenly spaced x values. So that's why we're trying square root. So let's go ahead and do x2 minus x1. So if this is x2 right here, and that's x1 right there, for the first try, we'll do 3.6 minus 1.6. When we do that, we get 2. All right, now we'll take the next one. We'll do 6.4 minus 3.6. When we do that, we get 2.8. And now we'll do 10 minus 6.4. And we get 3.6. And then 14.4 minus 10 is 4.4. 19.6 minus 4.4 is 5.2. And the last one, 25.6 minus 9.6 is 6. All right, so obviously we didn't get the first number the first time, but we're going to try it one more time and figure out the second differences. So now we're going to do it again, x2 minus x1. So 2.8 minus 2, that is 0.8. 3.6 minus 2.8, that is also 0.8. 4.4 minus 3.6, we get 0.8. We get 0.8 here, and we get 0.8 here. So since we got the same number every single time, the second time we did this, and that was for the x's, we say the parent function for this is the square root one. So the shape of that, if you were to plot it, would look like that, roughly. All right, let's see if you can decide what to do with this third one. First thing, hopefully you're doing, is checking out those x's. Are they evenly spaced out? 1, 2, 3, 4, 5, 6. Yes. So let's see if it's either linear, quadratic, or maybe it's exponential. So let's check the first differences in the y's. So let's check y2 minus y1. So we're going to do 384 minus 512. When you do that, you get negative 128. All right, now let's do 288 minus 384. That's negative 96. Well, it's not going to be linear. Let's keep going. 216 minus 288 is negative 72. Next one, 162 minus 216 is negative 54. And this last one, 121.5 minus 162 is negative 40.5. Okay, so obviously it's not linear. This does not make a straight line. So let's try the differences in the y's again. So we'll do negative 96 minus, I'm going to write this out, minus negative 128. What's going to happen? It's going to turn to a plus sign. So when we do that, we get 32. So the first difference is 32. All right, the next ones I'm not going to write out, but make sure you're doing them right with your signs. It's going to be negative 72 minus negative 96. That gives us 24. The next one, negative 54 minus negative 72. That gives us 18. And then this last one, well, shoot, this isn't going to be quadratic either. I already knew that, but it's not going to be. Negative 40.5 minus negative 54. So that gives us 13.5. All right, we could keep going. We could try this again to see if we get cubic. So it would be cubic if when we do it again, we get the same number. It looks like this is going to be 8 and then, oops, down 8 and then down 6 and then down 4.2. So there, I tried it, and it's still not exact. So let's try the one we haven't used yet that they're trying to teach us in this section, and try the exponential. That one is when you take a ratio of the x and y values. So we knew it wasn't linear, we knew it wasn't quadratic. Let's try doing the ratio where we take y2 and we divide it by y1. Let's do that. So let's do 384 divided by 512. 384 divided by 512 is 0.75. All right, we're going to keep doing this. If we get 0.75 every time, then this is going to be exponential. So the next one we'll try is 288 over 384. We're always doing the second one divided by the first one. So let's type that in, 288 divided by 384, and we get 0.75. All right, let's keep trying this. 216 over 288 would be the next one we would try. 216 over 288. And we get 0.75. Next we would try 162 over 216, and then finally the 121.5 over 162. And we are going to end up getting 0.75 every time. You should check every single one of them. I'm kind of out of space, so I'm just going to leave it like this. But since we got constant ratios, we would say that this family is exponential. All right, for this part, maybe you remember finding regression before. We did it in Chapter 6, Unit 3. If you weren't here for that or you forget, don't worry, you're going to get these notes so you can use them on the test to help you out just in case. But the first thing you're going to want to make sure to do is to turn diagnostics on. So once they're turned on, they should be left on. And you do that by pressing second 0. It'll take you to the catalog. And then you scroll all the way down to the D's. And when you get to where it says diagnostic on, you press enter and enter. Okay, you have to press enter twice. Enter, enter. And then it'll say done. Then you need to make sure that y1, y2, y3, etc. are blank. So go to y equals, and whatever's in there, clear it out. So we're going to enter our data in the lists. That's when you enter your table. All right, when we get to the problems, we're going to actually put that in, and that's when you press Stat and Edit. Remember, if you already have lists in there, to get rid of them, you press up to highlight L1 or L2, and then press Clear Enter. Clear Enter. And that'll get rid of the whole list. All right, either L1 or L2. I have to do it on my calculator right now. I'm pressing over to L1. You just press up to highlight the L1 and L2, and then clear enter. All right, so everything's cleared out of my calculator. We need to make sure the scatter plot is on. That means that you're telling your calculator to plot the points that you tell it to. So you'll press second y equals, and right now mine says that plot 1 is off. So I'm going to select plot 1 by hitting enter, and now it's blinking on top of the on, so I'm going to press enter on top of that. I'm going to make sure that it's on the scatter plot and that my x and y lists are L1 and L2. So that's all set. Did that. So once we have the data in, we'll press zoom 9, and that will show us the graph, and then we just have to look at the shape and try to decide which one we think it is. When you're deciding which shape it is, you can analyze the fit by looking at the r squared value, either the lowercase r or the capital R squared. The closer that number is to 1, the better the model is. At least that's the criteria we're going to use. There's lots of other ways to assess the fit, but that's what we're going to go with. So let's go ahead and try that for the first example. So I'm going to move this so I can see all the questions. And I'm going to press Stat and Edit. And I'm going to enter 5, enter 6, enter 7, 8, 9, 10 in L1. Press Over, and I'm typing in 124, enter, 150, 185, 213, 261, and 322. Now, both my lists are the same length, and so now I already made sure that plot 1 was on, so I can kind of skip that step, but I'm going to go ahead and look at the graph. So I'm going to press Zoom 9, and on my calculator, I see something that looks like this. Here's the screen, and I see kind of dots that look like that. It looks kind of curved if I were to describe the shape. So I'm thinking either quadratic or exponential. I'm not thinking linear. It doesn't look like a straight line. I'm not thinking square root because those ones look like that. So I've kind of already narrowed it down to 2 choices. So let's figure out which one it is. I'm going to do Stat, press the Over button to calc, and I'm thinking it could be quadratic or maybe exponential. So I'm going to pick 5 first for quadratic. So I picked that number 5. Now I'm going to press the Vars button over to Y, pick 1 for function, 1 for Y1, and hit Enter. And I see an R squared value of, let me just jot this down so I don't forget it, 0.9968. That's pretty good. All right, I'm going to jot this equation down just in case the exponential one is worse. So it's going to be 4x squared, and I'm just rounding it. It's 4.05, but I'm just going to round it to 4. And then the b is negative 22.2. I'm just going to leave it at negative 22. And then the c is 135.8. I'm going to round that up to 136. Okay, so that's the quadratic one. Now let's test the exponential. So I'm going to go again to Stat, start again, Stat, over to Calc, and now I'm going to press option 0, or I can scroll down to 0, and I'm going to press Vars, over, 1, 1, enter, and this R squared value is, this is a lowercase, this is for the exponential one, 0.9978, 0.9978, 9978. Okay, there's such a small difference between these two that the exponential one is a tiny, tiny bit better. If you're doing a quiz and you get these, if you decide between 2 of them, I'm going to give you a little leeway because there's not that much of a difference. But let's go ahead, since this one is technically a little better, and I'm going to write down the A value. It's 48.58. I'm going to round this to 48.6, 1 decimal place for the A. And then next to it, I'm going to write the B value, 1.2 to the X. And if you're wondering what format to use, the format's always, at the top of your screen, right underneath where it says exponential regression. So we're going to go with this. So that will be our answer for right there. If you press Y equals, you'll see that that has already been typed into the calculator for you. And so you don't have to worry about that. I guess we can recopy it right here. 48.6 times 1.2 to the X. Okay, so there's the equation. It's already saved in Y equals because that's what we told it to do. And now we can use that. If you want to look at the graph, press graph. You can see it draw that nice line that goes right through all your points. And we're going to predict how many buffalo there will be at year 9. Except for we already know how many at year 9. Let's go ahead and switch this to year 11. All right, what would the next one be? in the table? Well, we can look at the table on the calculator to figure that out. So let's go ahead and scroll down to the 11, and right next to it we see 383.5. Let's go ahead and round that up to 384, so about 384 buffalo. And then the last question, question C, is when will there be more than 500 buffalo? So we just have to look and see when that number in the y is greater than 500. And when you look in the y, you'll see the number 558 or something very close to that. That's the first time the number's over 500, and that is at my favorite number, 13. So your answer would be 13 years.